Okay, so I'll do my introduction a few slides in. Just to kick it off, thank you for joining today. I'm going to be talking about how to optimize Power BI semantic models for performance. Performance is very important when it comes to Copilot because you want your users to be able to ask questions and get the answers in a timely fashion. And then we'll talk about how you can optimize your semantic models for using Copilot for Power BI. These are the objectives for today. We'll start off by understanding current enterprise vision for data-driven decision-making in general, especially why Power BI performance and Copilot readiness are critical for business impact. And then we'll move into practical strategies that you can apply in your own enterprises for optimizing Power BI direct query performance. We'll talk about some common bottlenecks and how to apply high impact tuning techniques. And then we will talk about how to design semantic models that enable Copilot and AI-driven insights, a lot of best practices there around things you can do to make sure that the end users get the best experience possible. There are a couple of demos, and I do like my sessions to have discussion. So if anyone has any questions or comments today, definitely feel free to jump in and add to the conversation. You can also post it in chat because I'll be monitoring that, or raise your hand within Teams. So here's the agenda. I'm going to start by doing an introduction and talking about why this topic matters, and then we'll move into the first topic, which is direct query performance tuning. And then after that, we'll talk about how to design your semantic models for Copilot and Power BI. So who's presenting? My name is Jen Beiser. I'm a Principal Cloud Solutions Architect at Microsoft. I've been with Microsoft for 7 years. My anniversary was actually yesterday, so it's 7 years and 1 day now. I focus on Fabric specifically, and I go very deep into the Power BI platform. I've been with Power BI back when it was just part of Excel, and I do a lot of performance tuning workshops with my customers. So I'm going to share some of those tips with you today. Oh, and I'm also based in Southern California. I actually lived in Dallas for a few years. It was over 10 years ago, but when I was there, I always wished that I was in Austin because Austin seems like a lot cooler place to be than Dallas. Okay, so let's just start off with an overview of Power BI. Today, Power BI, as you know, it extends to everyone. IT uses Power BI, business analysts use Power BI, pretty much everyone in your organization can use Power BI. Often turning data into business insights can be challenging. Common challenges include, first of all, organizations want an end-to-end view of all of their data. Oftentimes, they have data that lives in different data stores. The data stores might not be easily accessed in a way where you can see the data in all of the different locations together. And so that makes it very difficult to get a complete picture of the business. Additionally, you might have multiple data sources. You might have data in cloud solutions. You might have data on premise. Sometimes it's difficult to access that data. They might refresh on different schedules. And then the third challenge is the different roles have different needs, and business users typically need the latest operational data. There are different BI tools that can be used to move past those challenges. However, I just want to call out that Power BI is a leader in the Gartner Magic Quadrant for analytics and BI platforms, and it has been for the last 18 years. Power BI has a high value for the price. It's a comprehensive analytics solution. Management is centralized. It can scale globally if you're a global organization, and security, governance, and compliance are built into the platform itself. And so Power BI really enables you to experience your data. It gives you fast, easy access to your data. It's really easy to get started with Power BI. I mentored a team of students here in Southern California. It was USC Long Beach on using Power BI to build an application for students to be able to find housing by combining data from different data sources. For example, the census, they might want to know about income information. They want to know about safety information, prices, things like that. And so this group of juniors and seniors at USC Long Beach were able to use Fabric to build out that analytic platform, which just proves that it is really easy to get started with using Power BI. It also allows for data discovery and exploration from any device. Collaboration is built in, and more recently, we have Copilot for Power BI, which brings AI tools and insights into the platform. Um, and so the AI tools and insights are built into the experience with Copilot. Copilot can be used for both business users and tech users. The business users might want to be able to quickly get the information they need by using natural language instead of relying on the visuals themselves. They also need to be able to trust the information, and Copilot can help with that as well. The data developers, they expect to be able to understand the data they're working with. For example, if you get a new developer on your team, they can get onboarded much faster because they can use Copilot to understand the data in the semantic model. Copilot can also be used by developers to create the reports themselves. They don't have to perform the root tasks like studying the data, choosing the correct visuals to use, and then making sure the visuals are attractive and well laid out on the page. So just know that Copilot can be used by both personas. And so why does Power BI performance and Copilot readiness matter? They're really strategic enablers. If Power BI is optimized and AI ready, it's going to be a faster experience for the end users when they're asking questions about the report or they're using Copilot to design new visuals. It's a faster experience if the semantic model is optimized for performance. It can also help you save money. It's going to use a lot fewer CUs if you have a well-designed performant model. Um, Additionally, it's governed. All of the data within Fabric that's consumed by Power BI is governed centrally. It also needs to be accessible and AI enabled so that the users are having the best experience when they start using Copilot. So let's start with performance tuning. Users want to get the data they want when they want it, and they don't want to have to spend a lot of time looking at spinning circles or multitasking while they're waiting for the visuals to populate. So I don't know if this has happened to any of you, but it has happened to me before where you're in a leadership meeting and you are waiting for 30 seconds, 1 minute for a dashboard to load so that you can describe metrics to your leadership. And no one wants to be in that situation. And so it's really good to make sure that your direct query semantic models are tuned for performance. As you know, there is an import option in addition to the direct query option. Direct query is typically the first choice if you have a lot of data in your organization and the data needs to be presented in near real time to the end users. Cleaning and optimizing that data is necessary in order to have good performance and response times. And so there are 6 key principles that can significantly impact the performance of your direct query reports, and we're going to talk through each of them. First of all, star schema. Next, query folding, and I think that one's probably the #1 area where you can get performance in your semantic models. Next, referential integrity and data reduction. Additionally, you can create both user and auto aggregations. We'll also talk a bit about the gateway and capacity settings. There are different tools that you can use when you are optimizing your performance, and I'll share with you what those tools are. And so first of all, star schema. If you're new to data modeling, star schema is the number one thing that you can do with Power BI to optimize for both performance and Copilot usage. If you're not familiar with star schema, basically it is having a fact table that includes all of your measures, which are things that you're aggregating. And so think about customer churn, sales, and things like that. And so your fact table is going to have that information as well as pointers to the descriptive information. And so the end users might want to see sales by customer. And so you would have a customer dimension and a sales fact table. And this is very important for both performance and Copilot, as I mentioned. If you have one large flat table in your semantic model, you're going to have poorer performance because you're loading a lot more data than you need to load. If you think about a denormalized table, for example, so I have one flat table that has all of my sales, and for each sale, I'm listing out the customer name, the customer address, the customer demographics. And so you can imagine how that information would repeat on multiple rows. And so if that's repeating on multiple rows, you're going to end up with a larger data set than you would otherwise have. It's better to have the customer information in a dimension table. And so you have one row for each customer. And then from the sales fact table, you're just pointing to that customer record. And that's going to help with both performance and Copilot usage. It also creates a simplified experience for your end users because when they are exploring the data, they know exactly where to find the information they need. For example, if I'm a business user, I have no technical skills and I need to create a report that shows customer sales by demographic and region, I can easily explore the semantic model and find my geography table and my customer table and my fact table and start building out a report. And the same is true for Copilot. Copilot is a large language model, and it relies on these relationships in your star schema in order to be able to provide answers to the end user questions. The next thing is query folding. So Power Query is built originally in Excel, and it's not really good at handling a lot of data in memory because Excel can't hold a lot of memory. However, this is the engine behind Power BI. And so your source system is always going to be able to provide greater computational power than Power Query. And so it's very important that Power Query can translate the queries that are being generated by the applied steps in your transform data into the language of your source system. So for example, if someone is filtering using Power Query, that needs to be able to translate into a where clause if you're connecting to Databricks, for example. And that is essentially what query folding is. It means that Power Query can translate the applied steps into the language of your source system. It's very important because your source system is always going to perform better than Power Query. Also note that if you apply a Power Query transformation that does not translate to the source system language, any subsequent steps after that step are not going to be able to go back to the source system either. So things that do not fold, if you're connecting to two different data sources. So for example, you're connecting to Databricks and SharePoint. There is no query language that can query both of those sources at the same time. So it's not going to be foldable. And any steps that you have after that merge or append are not going to be foldable either because it's already gone into the Power Query engine. So if you need to do things like merging, appending, things that don't fold, make sure that those are the last steps that you have in your transformation process. Query folding, it depends on the data source. For example, Databricks develops the Databricks connector, and so they control what folds and what does not fold. You can provide feedback to the vendors, and if they get enough feedback on what you would like to fold, eventually they might develop it into their connector. Sources that support folding, most of the sources that have a concept of some sort of query language support query folding. This would include OData, SharePoint List, Exchange, SQL, Databricks, most of them. Native query does not fold by default with some of the sources. You have to actually change the query that you're using in order to get that to fold. And Databricks is an example of a connector like that. If you just connect to Databricks and then you write a native query, which is the query that you post into the SQL statement box when you're connecting, by default, that's not going to fold. You have to modify the M query using the advanced editor and some specific keywords in order to make sure that that query is going to fold. Here is a list of things that can fold. Removing columns, that is just doing select alias instead of select star. Renaming columns, most query languages support aliasing. Filtering rows, that can be a where clause. Grouping becomes a group by. Expanding your columns to join two tables together that are based on the same data source is foldable. If you're doing merging of two queries that are from the same data source, that is folding. If you're appending your queries based on the same data source, a query can be written to do that, foldable. As well as adding custom columns with simple logic and pivoting and unpivoting. If you have two different sources, as I mentioned earlier, then merging is not supported because you can't write a query that connects two different sources together. Additionally, if you're using complex logic, that might not be foldable. Adding index columns is not foldable, as well as changing a column data type. And I see a question from Jose. So native query is when you're in Power BI and you connect to your data source. So let's just say you're connecting to Azure Databricks. And if you go to the advanced properties, you have the option to write your own query instead of selecting a table. And so in Power BI, you cannot use a stored procedure in a native query, but you could write your own SQL query that would select the data that you're looking for within that box. And so that's what a native query is. Did that answer your question?
Yes, thank you.
Yep, absolutely. So the next tip is referential integrity and data reduction. Data reduction is pretty straightforward. Don't pull any data into your semantic model that's not being used by the visuals or by the end user. There's a tool, free download, called Measure Killer that you can use to identify those fields. And then referential integrity, if you have ever created a relationship between two tables in Power BI, you may have noticed a box that's assumed referential integrity. If you check that, that means the query that Power Query generates to send back to the source system is going to use an inner join to connect those two tables instead of a left outer join. Inner joins always perform better than left outer joins. So if possible, be sure to check to use the referential integrity. And I just make sure I didn't skip. Yep. Okay, next, user and auto aggregations. There's two different aggregations in Power BI. User aggregations require technical competence to develop. The auto aggregations are pretty straightforward. They're both built on the same architecture, but they are just built differently from the development perspective. The user aggregations, the developers define. These are just tables or views that exist on your source system. You have to build them out, and they cache aggregated data that's frequently accessed by the reports in memory. You would create an aggregate table, import that into your semantic model, and the way that Power BI is going to work is if it can get it from that, if it can get the data from the imported table, it's going to use that instead of going back to the data source. And so you can get some really good performance gains there. Built on the same architecture as auto aggregations, and these are created by AI. They look at the query log behind Power BI to see what information is frequently being aggregated in your reports, and they automatically create the aggregations that are imported into memory that can serve a specific percentage that you define of the queries that are generated by Power BI when the users are interacting with the reports. Next, this is really important. Every month, as you probably know, there's a new release to Power BI Desktop. There is also a new gateway update that is released each month. It is very important to make sure that Power BI Desktop and the gateway are using the same version. And so make sure that you are updating your gateway every month if you're using a gateway. Currently in preview, and if you are connected to Microsoft currently, you can join a private preview of auto on-premise data gateway updates, and that would remove the overhead of updating that manually each month, but definitely make sure that you're updating your gateway every month as well. It's also recommended to have a separate gateway for import and direct query. You should use multiple nodes with load balancing. Make sure that your spooler directory is using SSD drives. This is specifically for import models. Whenever you have an import model, Power BI writes all of the data to a disk when you do a refresh, and it's really important to make sure that's an SSD drive. You can disable using spooler directory if you would like, but if you have network failures, you might end up with an incomplete semantic model because it's writing the data to the web service before all of the data is loaded. And there's a couple other tips there that are important. Definitely don't have your on-premise data gateway and your Azure Data Factory self-hosted runtime on the same machine. Those should be separate. By default, the gateway does log metrics, and there is a Power BI template. I'm linking to it in this slide that you can download to get a lot of insights into the gateway performance. Okay, so some tools that are good to use when you're performance analyzing your semantic models. First, Performance Analyzer within Power BI itself. If you're going to use Performance Analyzer, make sure that your report has a blank page, and then go to that blank page, save the report, close it, and make sure that when you open the report, it opens on the blank page. That's because the Power BI UI actually caches data. And so you don't want that to skew your performance metrics. It's really important that before you start Performance Analyzer, the report has been opened on a blank page. There's also DAX Studio. That's a free download. You can export the Performance Analyzer data as a JSON file, and then you can import that into DAX Studio, and you can execute or re-execute the code that was executed during the direct query refresh of the visuals on a page. And that's going to give you insights into which visual might be the bottleneck. You can also see the actual queries that are being generated by Power Query. You can't modify those queries directly but you can look at patterns kind of in what it's doing and figure out how you could optimize your report. So for example, if you were to run your performance analyzer results in DAX Studio, you might find that the tooltips on one visual are what the hangup is, and then maybe you could reconsider including those tooltips in the visual and see if that gives you better performance. There's also VertiPack Analyzer that's built directly into DAX Studio. VertiPack Analyzer is going to give you insights into the shape of your data. You might find duplicate columns just by looking at the statistics of the columns, and then that can help you with data reduction because maybe you could remove those columns. There's also Measure Killer. I mentioned that earlier. It's another free download. It's going to show you the fields that are not being used in your visuals. It's important to consider that the end users might still be using those fields, even if they're not in the visuals. Just keep that in mind, but that's a really good tool for data reduction. And then if you have an import semantic model, it's really important to tune using diagnostics. That's another tool that's built directly into Power BI Desktop. What you would do is you would go to transform data, you would turn on diagnostics, make sure you don't close the transform data, just minimize it, and then you can do a refresh, and that's going to give you a lot of metrics into the semantic model refreshes. There's also a template that Microsoft can share with you that can give you a Power BI template that can give you pre-built visuals that give you insights into that diagnostic information. Okay, so if anyone has any questions, feel free to ask them. Otherwise, I'm going to go ahead and start with, I'm going to show you a little demo.
I don't see any questions so far.
Okay.
Sean, you have anything? Okay. Oh, yeah, you're saying auto.
Nope.
Okay.
Okay, let me get rearranged a little bit. I have a huge monitor.
And Jen, do you know the Fabric has a gateway? Is it still staying? You know, or gateway component?
Yeah, same.
That we don't have to have a resource. It's part of the Fabric resource, isn't it? The Fabric
It
gateway.
is. If you go to the data connections in Fabric, or I'm sorry, the data gateways, first you go to data connections, and then there's a tab for gateways. You still see them exactly how you did in Power BI.
Okay.
Okay, so some things that I talked about. First of all, query folding. If you're using an Azure data source, this isn't going to work with Databricks. You can right click on your step. And if you have the option to view native query, that means that the query is foldable. If you don't have that option, it means that the transformation is happening within Power Query, and that's never going to perform as well as it would if it was executing against your data source. Let's see what else. Star schema. And so if we look at the model behind this one, this is my optimized file. You can see that I have relationships defined here. Here's my trips. And so this would be things that we're aggregating. For example, count of trips, tip percent, and then all of the descriptive items are in their own table. That makes a really good end user experience because they can find exactly what they're looking for. I'm also using a user-defined aggregate table here, which is a view that I created on Databricks and imported into my semantic model. And then I connected it to the relevant dimensions. And so if someone's querying my report, assuming this information is in my aggregate table that's been imported, it's going to use that data instead of going back to my trip table. And the way that you do that is you go to manage aggregations after you've imported it, And so, for example, my average temperature, I'm doing a sum, that might not make sense, fair amount sum. And so you just point it to the field in your fact table that you want the aggregation to use. That's really easy performance gain that you can get. You can also set those up in the Power BI web service. If you go to the settings of the semantic model, you can enable auto aggregations, and that's going to eliminate the need to create the aggregation table yourself. However, you don't have as fine-grained control over it because it's entirely based on AI. Okay, back to my slide. Okay, any other questions before we move on to talking about Copilot? All right, moving on. If anyone thinks of anything, feel free to put it in the chat. Okay, so let's talk about optimizing for Copilot specifically in Power BI. If you are not familiar with Copilot, um, it is a large language model within Power BI that allows users to interact with the Power BI reports using natural language. Do note some people are scared of AI. People are not going to be replaced by AI. They're going to be replaced by people who use AI. And so it's really important to understand how to use AI effectively. And so, as I mentioned earlier, different personas can use Copilot in Power BI. It can be your developers, it can be your admins, it can also be self-service users in addition to business users. And so just like designing for performance, designing for Copilot is key to make sure that your end users have a good experience when they start using it. Um, I spent hours working with different customers, Microsoft customers, to optimize their semantic models for end user Copilot consumption. And through this practice, I was able to document some of the key best practices. This is documented by Microsoft in general, but it's not really consolidated into one location. And so it was a really good experience to be able to put all of this information together. The first tip, clear names. Second tip, don't use abbreviations. Third tip, relationships are really important. It's good to have hierarchies as well. Set your default categories and aggregations. The gateway and capacity settings are important here as well. Make sure that you're mindful of your data types and your formatting, and always include time intelligence. So let's go through each one of those. Copilot looks at your table names semantically, and so it's important to make sure that it's able to recognize which table is the fact table. And so definitely name those after actions and events. For example, sales transactions, customer interactions, or inventory movements. That really helps Copilot understand the purpose of the data, and it improves the insights that it can generate. Next, no abbreviations, unless they're commonly known abbreviations. But if you have proprietary abbreviations in your organization that somebody off the streets would have no idea what it stands for, and Microsoft were known for having tons and tons of acronyms, but definitely don't include those in your semantic model because Copilot's not going to be able to relate that name back to the question that the end user is asking. Next, relationships are really important. Just like end users can understand the relationships between tables. So, for example, I have a sales table, I have a customer table. The sales must be, the customer must be participating in the sales. The customer must have bought something, and you know that by default when you have a customer table and a sales table. And Copilot is the same way. It needs to have those relationships to make sure that it understands how the data in your semantic model is related. And so if you have one big flat table and you're not using a star schema, Copilot is not going to be able to provide very robust answers to the end user questions. As an example, I had one customer that was using just one flat table, and they would ask Copilot to create a new report page. And the only thing that Copilot could create was one card visual with a count of some field, and it was not a good experience. And so it's really important to make sure that you're using a star schema. Next, if you have location data in your semantic model, for example, region or dealership or store, it's really important to set the default category for that. In Power BI, there's a category setting that you can apply to each field. And so, for example, if I had a dealership field, I would set the category to be place. And that's going to help Copilot recognize any location fields so that it can create geographical based analysis. Also, by default, Power BI aggregates any integer fields. Some fields you don't want to be aggregated. For example, store ID, you wouldn't add all of those together. And so make sure that you're correctly setting the default aggregations. Store ID would be do not aggregate. You might have percentage fields in your semantic model. You would probably want to average those instead of summing them together. And so make sure you're setting the default aggregations appropriately. Next, default categories and aggregations. Ooh, I used the wrong title for this one. So the first one is to hide the key columns. The key columns are used to tie your fact tables to your dimension tables, but they're rarely used for analysis. It's good to hide them. First of all, it declutters the model and it makes it an easier experience for the end user. And it also, if you hide them, Copilot can no longer see them. And you don't want Copilot to consider those fields when it's answering questions. You can easily do that by using Prep for AI, which is a new tool within Power BI. That's going to allow you to multi-select all of the fields that you don't want Copilot to consider and make sure that they're hidden from Copilot. I mentioned before Measure Killer in regards to performance. It's really good for Copilot as well, especially when you're thinking about cost management. If there are a lot of fields that aren't being used or considered, you probably don't want Copilot to consider those either. The larger your model, the more time it's going to take for Copilot to come back with an answer for you. And if you have a lot of fields that aren't used, it might answer with something that's not necessarily relevant to the end users. Next, make sure you're using mindful data types and formatting. When Copilot is responding to the questions, it's going to include data in the response. And so if it's responding with a percentage, for example, you don't want it to respond with .25 for 25%. It looks a lot cleaner if it responds using the percentage sign and says 25%. It also helps Copilot interpret the appropriate operations. If you have a percentage field, Copilot would most likely know that it's more appropriate to sum that, or I'm sorry, to average that if it's formatted as a percentage. And so make sure that you're doing that as well. Time intelligence, really important because a lot of people want to ask about trends in their data over time. If you don't have any time intelligence measures in your model, so for example, same time last year, month over month, year over year, Copilot's not going to do great at identifying the things that have driven change in the data. And here's a real world example. If you don't have time intelligence, Copilot might say that the decline in variable profit for this product from Q1 to Q2 is evident. The profit dropped from this in January to that in April. It was this in May, but it's not really providing explicit reasons for the decline. If you have time-based metrics, Copilot's going to be able to understand the context of that change because it's going to be able to look at the time intelligence measures based on the attributes that you have in your model. And then finally, I was going to show the difference in responses of a Copilot based on when you have a flat semantic model, so you have one large table, versus when you have a star schema and you've implemented a lot of the suggestions that I've made here. And if anyone has any questions, definitely feel free to ask them.
Yeah, Jose, go ahead.
Sorry, I have another question. I am a post-degree student of data analytics here in Canada, but I can and I don't have the chance to use Copilot because it requires a specific license, and I understand. But the question is, how can I try Copilot if I don't have the license in the organization or anything else?
Um, so as a university student, you might have access to the Visual Studio Developer Program, is what it was formerly, MSDN, but now there is a new environment that you can spin up with credits from your university. And so I can track that down and send you a link, but you should be able to get at least, I think it's $200 in credits a month that you could use for Fabric.
And I think Microsoft allows F2, the lowest one now, for Copilot. Before it was I forgot F64 minimum, but now it's F2.
Yeah, that's correct. Yeah, so you would just have to spin up an F2. I forget how much they are a month, but you could definitely try it out with a $200 a month credit. And I don't have your email address, Sajad. Do you send out a recap after these sessions?
We do, but I'll say if you put your email address for Jen so that yeah, she can
Yeah,
send
that
it.
would be perfect. I'll send you the info.
Okay, perfect. I write it down in the chat.
Okay, cool.
Thank you.
Yep. Any other questions? We're going to move into a demo. I just wanted to do a check and see if anyone had anything top of mind. Okay, so let's move on to the demo. I have this semantic model. We saw it earlier. We have a star schema. We're using an aggregate table for performance. The tables are set up in direct query mode. You're going to see pretty good performance when I interact with it with Copilot. I have another file. And if we look at the semantic model here, I just have one trip table that has all of my geographical information. It's not categorized as geographic. We're using abbreviations. Copilot might be able to understand those because they're not proprietary. I'm not setting up the default aggregations here. It's just one flat table. And so I am going to ask some questions of both semantic models, and you can see how they perform differently. So for example, if I ask on the flat model, which city had the most trips? And just know, like, if Copilot can't answer a question based on the page that you have open, it goes back to the semantic model. And so that's what it's doing right now. It's going back to my semantic model, and it doesn't perform very well because this model is not optimized for either Copilot or Power BI. And while that's waiting for my response, I'll go ahead and ask it to the other one too. And so it said, oh, Manhattan, and here's your trip count. And you can see it's not formatted either. I mean, that would look a lot better if we had a comma or if it said approximately 8,000 instead of the specific number. And so if I ask the same question in my optimized report, I say, which city had the most trips? It should be a little bit faster because this one's optimized. So again, it's looking at the underlying data because it can't answer it based on this page. This page is aggregated at a level higher. I have the count of trips by a higher level than city. It also tells you how Copilot arrived at this. And so, for example, here's my answer. And then it says, you asked this. I used the trip table. I did a count of rows because this semantic model, as you recall, doesn't have any aggregations in it. And it also says that it used city. And then it just did a top one city by count of trip. And this one said the same answer as before, but it didn't provide it as a visual. And it's just showing me the count of it got it from the visual. It's telling me I got it from this visual here. I think that Copilot might be self-corrected because I've found that if I ask questions I asked in the past, the Copilot on the unoptimized report has a better answer than it did last time. And so I will ask something that I haven't asked before. For example, did let me look at my data. I forget what's in this. We'll ask, did the state of pickup affect have any relationship to precipitation? I have not asked that one yet. Or explain how. And you don't have to be grammatically correct with Copilot, just like any other large language model. It kind of figures out what you're asking, even if you don't ask it using the appropriate verbiage. So this one's asking for clarification. Do you want to compare average precipitation across pickup states, or are you looking for something else? Should it be, I'm going to say all data. And I'm thinking, I'm not sure, I haven't asked this question before, but I think it's going to have a hard time answering that because I don't have a relationship between the locations and the precipitation in the flat model, but I do in the other model, in the optimized model. And so over here, it looks like it's making a DAX query and then it's running the query. And over here, it's writing my response. And so this says only New York is present, which is not true. I have other states in here, as you can see over here. And it says that it was 0.1 inches for pickups. There aren't any other states shown, and that's not true at all. And over here, it answered a lot better. There's a tendency for more trips to happen when it's not raining. However, the relationship is not strong, and this is just a problem with my data where the average precipitation is always 0.11. But as you can see, the answer's a lot better when we're asking it from the optimized model versus the not optimized model. And so here it's just telling me the data it used. There were no filters applied. And then over here, it's actually showing me what the data looks like, which is a much better response than the other response. And so it is interesting that if I ask a question that I asked in a previous demo, that it seems to self-correct somehow. But if you ask it new questions, like the first time someone asks a new question, it's going to respond better if you have an optimized semantic model. And that's it. Any questions, or is there anything else that you want to see?
I think someone has a question about MS Office license on a laptop. I don't think so that includes Copilot. Has to
No,
be
Microsoft Office does not include Copilot. You have to have either a Power BI premium SKU, so like a P1 or a P2, and your admin needs to add you to the group that's allowed to use Fabric and Copilot. P SKUs are being deprecated, and so alternatively, you would have to have at least an F SKU that you have access to. Office is not related to Copilot.
Well, I think what you mean is that version of Copilot that you can get with Office is not the one that you need with Power BI to use Copilot there. Correct, Jen?
Correct, yes. Your organization would have to have an E5 agreement that automatically includes the Power BI licensing that you would need. And then they would have to assign that license to you.